Okay, so we use exponential regressions to model real world data that shows rapid growth or decay. So this could include things like population growth, the spread of a virus, or radioactive decay. So exponential regression help us to find an equations of the form y equals a times b to the power x, where a represents the starting value and b is the growth or decay factor. So most graphing calculators or utilities can generate this model from set of data points. So once we have the model, we can use it to make predictions and to understand better the trend and the data. Okay, so let's try an example to see how exponential regression works. So you can pause this video and take a couple of minutes to read this question and understand it better. So this problem is all about monthly premiums for 250,000 life insurance policy over 10-year period. So the 10-year period increases with the age of the males purchasing that insurance. So this table shows the monthly premium for non-smoking males at various ages. So the first part of this problem is to graph this data. So you can try to sketch a scatter plot. You can use age as the x variable, and you can use y variables as your premium. So here I have my scatter plot of the data. So here I have taken x-axis as the age and y in dollars or the premium. So if you try to analyze this plot, plot shows that the output rises rapidly. The output rises rapidly as the input increases. So let's move to the second part. So in the second part, our goal is to create an exponential function that models these premiums as a function of age. So here, let's use age as our input. So let's use age as our input. So this is going to be our x value. Next, let's be our output be the premium. So that is going to be your y value. So then we can use a graphing calculator or any other utility to find the best fitting exponential model of the form y equals a times b to the power x. So based on my calculations using the TI-84 calculator, so here's the exponential model I got. So these values have been rounded for 4 decimal places. So in this equation, x represents the age in years and y represents it gives you the estimated monthly premium. So in a follow-up video, I'll show you how exactly you can generate this model using TI-84 graphing calculator step by step. Okay, moving on, the third part. So in third part, you have to graph both data as well as the exponential function we found earlier in the same Cartesian plane. So here I have both points, the scatter plot, as well as the graph, the function we found earlier in part B. So this model appears to be very good because you can see both points and this function aligns perfectly with each other. But it's not that perfect. You know, this point is a little bit deviated from this graph, but it fits the data.